Okay, so coming to derivation of variance of the normal distribution, I'll just be considering Varx. Okay, in this format, I'll be considering minus infinity to plus infinity, x minus mu whole square, f of x dx. And I know for normal distribution, f of x is 1 by sigma under root 2 pi e power minus 1 by 2 x minus mu by sigma whole square dx. Okay. Why I'm considering this is I can go with the substitution x minus mu by sigma is z. Not exactly substitution. It is the standard normal variate z. Z is equal to x minus mu by sigma, or what would be the value of x? Mu plus sigma z. Okay. Now dx would be what? Sigma dz. Okay. Or dz would be dx by sigma. Right? So let's see what happens with these things. 1 by root pi is root 2 pi is as it is. Minus infinite to plus infinite. This value would be nothing but sigma square z square. Okay. Of course, this is sigma outside into e power minus z squared by what's it? By 2 dz. Yeah, sigma dz, I'm sorry. Yeah, sigma dz. Okay. So this sigma and this sigma goes off, right? Yeah. Let me rewrite it once again. Sigma square can be taken out by root 2 pi integral minus infinite to plus infinite z squared into e power minus z squared by 2 dz. Clearly, this integrand is an even integrand is an even function. So clearly I can write like this. Integrand is an even function. Even function. And I know when an integrand is an even function, how do I write? Integral from minus limits to plus limits, minus a to plus a. F of x dx would be what? Twice integral 0 to a f of x dx. If it is an odd function, then its value would be 0. Integrand value would be 0. Okay. So I'll be writing that version of it, sigma squared by under root 2 pi into twice integral 0 to infinite z squared e power minus z squared by 2 dz. Okay. I can go with the substitution. Okay. I can go with the substitution where z squared would be some t or something. Okay. Let z squared by 2 I can take as well. By 2 is equal to t. So 2z by 2 dz is equal to what? Dt. Right? Z dz would be dt. But I have z squared, guys. So z into z I have to write. One z dz would be dt. Fine. But there'll be one more z, right? So I have to find the value of z as well from this equation. What's that? Z squared is equal to 2t. Z would be what? Plus or minus root 2t. Okay. Since I am taking from the interval 0 to infinite, I'll be skipping off this minus and going with only plus. Sigma squared by under root 2 pi into 2. Okay. Now I can just see for t is equal, for z is equal to 0, t would be 0. For z is equal to infinite, t would be infinite, right? So no change in the limits, integral 0 to infinite. Okay. Z dz value would be what? Dt. E power minus t would be there. Now, For the other z that is remaining from z squared, what I'll have would be root 2 is there, root t is also there, right? That t I'll be writing it to be t power 1 by 2. Okay, just see here, root 2 gets cancelled off with this root 2. Okay, so sigma squared by root pi will be remaining into 2 integral 0 to infinite t power 1 by 2 e power minus t dt. As discussed in the earlier video of mean, I know that this value is nothing but my gamma integral. Let me see what the value of gamma is. Okay, just see, gamma of n is what? Integral 0 to infinite e power minus t power n minus 1 dt. What do I have in the place of n minus 1? N minus 1 in the place of n minus 1, I have 1 by 2 here. So what would be my n? N would be what? 1 by 2 plus 1, which is 3 by 2, guys. Okay. So I know clearly that sigma squared under root pi into 2, this integrand value is what? Gamma of 3 by 2, I can say. Gamma of n, na? So gamma of 3 by 2. Now, one more property of gamma, please see here. When gamma of n plus 1 is there, n into gamma of n is what I can write. Okay. So let's see what happens. Of course, this property is also there, guys. Gamma of n is equal to n factorial. But for the fractions, I can't find the factorials, right? So I'm not using this formula. I'm using this formula, right? Sigma squared by root pi into 2, I'll be writing gamma of 3 by 2 as 1 by 2 plus 1. N is what? 1 by 2. So n into gamma of n. That is what? 1 by 2 gamma of 1 by 2. Okay. I've already mentioned in the previous video what the value of gamma is. Sigma squared by root pi, guys. This 2 and this 2 gets cancelled off. Gamma of 1 by 2 value would be root pi. I've mentioned in my previous video. Do check my previous video. I have proved it as well. Okay. For mean of normal distribution, right? So these two get cancelled off. I'll be having sigma squared to be the variance of normal distribution. Fine. This is how I will prove variance of normal distribution. Let's see some problems on normal distributions in the next video.